In this video, we're going to solve 2005 Calculus Form B question number 4. So, the graph of function f above consists of 3 line segments. Let g be the function given g of x equals x to negative 4 f of t dt for each of g of negative 1, g prime of negative 1, and g double prime of negative 1. Find the value or state that it does not exist. So, if we want to find g of negative 1, let's do a down here. So g of negative 1 is going to equal negative 4 to negative 1 f of t dt, which is going to be from here to here. So we're finding the area of a trapezoid. So now you're going to have 1/2. The height is 3. The first base is 2 plus 3. But remember, this is underneath the x-axis, so it's going to be negative. So now we're going to get 1/2. What's that? 15. So negative 15 halves. That's your answer for that part. So this part right there is going to be negative 15 halves. Okay, next question. Find g prime of negative 1. G prime of negative 1 is going to be f of negative 1. F of negative 1 is whatever the y value is, which in this case happens to be negative 2. And the last part for part A is g double prime of negative 1, which is not going to exist, D and E, because it is not differentiable there. It forms a corner because it is non-differentiable. Okay, part B says, for the function g defined in part A, find the x-coordinate of each point of inflection of the graph of g on the interval from negative 4 to 3. So we can't include the endpoints, but a point of inflection is where it changes signs. So let's look. Negative 1 is positive to positive, so this is positive to positive. It's the slope of the slope, right? So it's increasing. This is positive to negative, so it looks like the only point that's going to be is x equals 1, because g double prime of f, it asks for a point of inflection, right? G double prime of x is equal to f prime of x, which is increasing and decreasing at x equals 1. Okay, part C, and I'm going to switch colors for part C. So part C says, let h be a function given by h of x equals x to 3 f of t dt. Find all the values of x in the closed interval from negative 4, which is less than or equal to x, which is less than or equal to 3, for which h of x equals 0. Okay, so now we're going to have to think a little bit over here. One point that I could definitely tell you is going to be 3. And the reason for that is, if you go from 3 to 3, you went absolutely nowhere. And if you went nowhere, that has to equal 0. Now, we're going to have to find equal areas. So if you find equal areas, let's look over here. That's and that. Those look like equal areas. So that area is equal to that area, right? So definitely another place where that's going to occur is going to be h of, what is that, 1? Yeah, 1. Which is going to be 3 to 1, 3 to 1, which you should technically negate it and switch the signs f of t dt, which is also going to equal 0. And then the last point is going to be, this is also an area of 1, and that's an area of -1. So those two areas are equal. Let me switch colors so it's a little bit clearer. Let me do red, and let me go back. So if I shade this area, that's +1, and this is -1. Okay, so h of -1 also equals 0. And I should switch these, but it's not going to make a difference because it's 0. Okay, part D. For the function h defined in part C, find all the intervals in which h is decreasing. Explain your reasoning. Okay, so now you have to think about this. It's 0 at 3, right? So if it's 0 at 3, we need to think kind of in reverse order. So h prime of x is equal to f of x. And now if you're working in reverse order, if this is 0, that point right there, now if we're working in reverse order, you're traveling downward to this, right? So that's going to be a max, right? You're traveling, no, that's going to be a min. And over here, you're traveling upward to it, right? If you're traveling upward, then that has to be decreasing, right? Okay, part D wants to know, where's h going to be decreasing? So now we're going to work in reverse order. So h prime is going to equal f. And now, since we're working backwards, you have to remember your integrand is written this way. There's a 3 here, there's an x here. So it's going to be in reverse. So when you think about this, this is decreasing, so it's really increasing because it's the opposite, right? And actually, nope. Let me pause that. Okay, so for part D, it wants to know where h is decreasing, right, on all the intervals. So we're going to be working backwards. So now, if you think about h prime, it's equal to f of x. And now, if you have this integral, 3 to x, you're working in backwards, right? So if you put in a number, you're looking for a place where it's positive in the backwards position, right? So if you look over here and you try doing 3 to 0, that part's increasing, right? There's not a question that's increasing. But the fact that's increasing and you have to switch the order of the integral, now you get 0 to 3, then it means it's really decreasing. So it's on the interval from 0 to 2. That's the only place where it makes sense. I hope this video helps.